Rightio, g'day students, and welcome to one of our more interesting lessons of the year. It's expanding algebraic expressions. So the point of today's lesson is that you should be able to use the distributive law to expand and simplify expressions with one or two pairs of brackets. The key ideas is this idea of the distributive law. Now it comes with two ways of being expressed, one with one bracket and one with two brackets. So for one pair of brackets, the distributive law equals, well, let's have a look at this. A times, open brackets, B plus C equals A times B plus A times C. And we'll have a bit of fun looking at this. So what we're doing, you can see that we are, oh, that's a wrong colour. We have got a, let's find a highlighter. It's blue on blue. See that I've carried that through. Now, we've got a common factor outside the brackets. So you can see that I've placed that common factor out twice. Now, the uncommon factor, here's our B. So that goes there. And our other uncommon factor goes there. Now, for two pairs of brackets, the distributive law looks like this. A plus B in brackets multiplied by C plus D in brackets equals A times C plus A times D plus B times C plus B times D. And we'll have several ways of explaining this. And the first way I would like to do is through a simulation or an interactive, and that's our area model simulation. So if you, so we're in PhET interactive simulations. And let's have a look at a square. Now, this square is 20 times 20. It's got a total area of 400. That's pretty straightforward, isn't it? So 20 times 20. But what if I were to break that 20, the top 20, into two? So let's say now it's 20 times 20, or we can say it's 20 times 11 plus 20 times 9. Now I can express that as 20 times 11 plus 9. So this is the factorised form of the distributive law, and that's with one bracket. Now I can show you some solving with that, can I? So what we're saying is, well, this equals 20 times 11 plus 9. Well, that's 11. We can always put the answers in too. Is that going to be nice? Let's have a look. So 20 times 11 is 220, and 20 times 9 is 180. So we can just now say 220 plus 180 equals 400. So that's the distributive law with one set of brackets. Let's see if I can play with this a little bit more and get two sets of brackets. So now we're really just saying, well, let's hide that for a moment. And no, well, this is what, 11 plus 9, so that's our second set of brackets. 11 plus 9 equals 20, and we've got 12 plus 8. Well, that's times, they add to equal 20 as well. So, we've got a bit of calculation going on. So, we can say 20 times 20, but what we're saying here now is we've got 12 plus 8 and 11 plus 9, so we've got four different squares. So we've got 12 times 11 for this little rectangle, and then 12 times 9 for this little rectangle, and that's seen down here. And then for this little rectangle, 8 times 11, so you can see that here. 8 times 9 is this little square. Now, that's the same as saying 132, 108, plus 88, plus 72. Now, they'll all add to be 400. So that's one way of considering the distributive law and expanding through the distributive law. So the important points today. Let's have a look. When we look at the distributive law with one set of brackets, we're just saying, well, B minus C equals A times B minus A times C. Or A plus, we can also write it in the positive form, and that's just what AB plus C equals AB plus AC. Remember, if you don't see any space there or any other symbol, it's multiplied by. So, whoops. Okay, now the two sets of brackets looks like this. A plus B in brackets multiplied by C plus D is, we've got 4 different terms. So the 3 different ways of thinking about this. And the first way is with rectangles. And I want to just run you through this. So remember, to get this first one, we're just going to multiply those 2 terms together. Now we're going to have to multiply that one with that one to get this, the area of this little rectangle. And then down here we've got A and we've got D, and then we've got a D and a B, and that's a bit messy, so just get rid of those arrows. And essentially we have 4 different terms. Now if we have a look at that, we've got 4 different areas, and we can add those areas up together, and that's what I was just showing you with that interactive. So it's just AC, which is this one, plus, and this one's BC, or CB, same thing, and then AD, which is this one, and BD, which is this one. In fact, I will put this in alphabetical order because although it doesn't really matter, it does look better, and try to keep things in alphabetical order if we want to. Now you can see that they're all different terms, and you can't add or subtract them because they are not like terms. Now the second method of doing this is through FOIL. So we look at our first terms, the outer terms, the inner terms, and the last terms in a set of brackets. So if we've got here A plus B multiplied by C plus D. So let's look at our first term. So this here is our first term in this bracket, and this is the first term in this bracket. And you can see that I've just said AC, so for the first term. Now the next one is outer. So this one is an outer term, and this one's an outer term. So A times D, and so that's my second term over here after I've expanded. Now let's have a look at our inner terms. Now inner means next to each other. So we've got our inner terms, so that's BC, and then we've got our last terms. So, and that's BD. And so you can see that, yeah, we can also expand a set of brackets using the distributive law, using FOIL. The last one is the crab claw method, and this is a little bit of fun, but it works. So what I might do is I'll delete them, and we'll talk about them. So what we're doing is we're multiplying this term here by that term there. So basically we want to multiply our first term in the brackets by the other 2, and then we've got A times D. Now we want to get our second term in the first set of brackets and multiply it by the other 2. So looking at that, our first one, our first bracket is B then times C for this one, and then the second term multiplied by the second term in that bracket. Now that kind of looks like a crab claw, so that's a bit of fun there. Now we're going to do a little bit of this, and we're going to just try to expand each to remove the brackets. So this is one set of brackets. So just to solve this, we're just going to say, well, this equals 3 times k. Now that symbol goes straight down, plus 3 times 2. Now 3 times 2 is 6. So simplified or expanded, well, let's say it's expanded first of all. We'll simplify others later. So that just becomes 3k plus 6. Let's look at the next one. This becomes 4x. Then I carry the operator down, minus, and 7 4s are 28. So this is factorised here, and this is expanded in this line. This one's a little bit trickier. We've got negative 5 times 3a. So remember, when we're multiplying, we're going to multiply the coefficients together. 5 3s are 15. Negative 5 times 3 has got to be negative 15. Now we just do the coefficients next. Now we go plus, because we've carried that down, but negative 5 times 8 is, or 5 8s are 40. I'm going to say plus negative 40. Now we can see that we've got a plus and a negative. So I can rewrite this to say equals negative 15a take 40. And we'll look at two sets of brackets. I might do crab claw first of all. And let's have a look. I want to get this term and multiply it by this term. And I get this term and multiply it by this term. So the first term in the first bracket multiplied by the second two, and then it's that one multiplied by those two. So let's do them. So we've got a times b, so that's our first one. A times b. Now that's got a plus in front of it, and that's got a plus in it. So it's all pluses, so that's nice. Now we're going to go plus 9 times b. And then we'll go to our second term. I think I've done that wrong, sorry. I've got to do it this way. Plus 2a, my mistake. I had to multiply that one by that one first. Sorry to lead you astray there, folks. Okay, and then we're going to get the second term here and multiply it by the other two in the other brackets. So that's going to be plus 9b and plus 18. 9b plus 18. Now if I look at all of these terms, none of them are like terms. So we are going to just not worry about simplifying it, because that's as simplified as much as possible. Now let's FOIL the other one. So remember, FOIL is first, outer, inner and last. So I'm just going to mark my first. That's my first. Now I'm going to go down here and go outer, outer. That's going to be inner, and that's going to be last and last. So let's work this through. Multiplying my first terms through together, x times x is x squared. Now, what have I've done my first, now I need to do my outer. So that's negative x multiplied by negative 6. So that's going to be negative 6x. Now let's do my inner. I've got a plus 4 multiplied by x, so that's plus 4x. And then last of all is 4 times negative 6. And 6 fours are 24, and it's a negative, so that's going to be negative 24. Now you can see here that I've got two like terms. This negative 6x and this positive 4x. So I can simplify this down. And that just becomes x squared. Now, negative 6 plus 4 equals negative 2. And then I add the coefficient in, then take 24. So that's those two simplified. I might do a few from your book as well, just to help you get around it. So remember, we're going to go, this is equal to 4a. Carry that plus through, plus 4 times 3, which is 12. Let's have a look at this one. 6 times 4 is 24, plus 6 times e, so that's 6e. Let's have a look at this one. Negative 4 times x equals negative 4x. And then I've got a negative 4 times a, negative 9. A negative times a negative is a positive. And 4 times 9 is 36. Let's look at this one. We've got 6 times 3m. So I need to multiply the coefficients first. 6 3s are 18. And then I put an m. Then I carry that plus through. And then it's just 6 times k, which is 6k. You should be working on some of the other columns here too. I just have a look over at P, because that's probably one of the harder ones. And let's have a look at here. We've got negative k multiplied by 5. So that's negative 5k. Then we've got a plus negative k times 3k. So do the coefficient, then negative k. I have to put a negative in there first as well. Okay, I'll just do this way. So I've got a positive and a negative now. So positive and negative equals a negative. And then we've got a 3k, and a k times k is a k squared. Now, this is just the previous example, but we've just been putting an extra term in here just to help you to collect like terms and simplify. So it's 3 times x plus 3 times 2 plus 8x. So it's 3 times x plus 3 times 2 is 6 plus 8x. Now we just collect like terms and simplify. 3x plus 8x is 11x plus 6. Likewise, let's have a look here. We've got a times b equals ab. A times 4 equals 4a. And then we've got to take a 2a. So that simplifies down to be ab. And our 4 take 2 is 2. So that becomes ab plus 2a. This one, let's have a look. We've just put the brackets over this side. So this is going to be 5k plus 2 plus now 4 times h, or 4h, take 4k. Are there like terms? I can see 2 like terms here. There's this one and this one. So all I'm going to do now is just go, well, 5k take 4k, that's 1k, but I just write k because we don't need to put in the 1, plus 2 plus 4h. Let's have a look at this. We've got 2 sets of brackets this time. Now, because I'm running out of space, I'm just going to do d down here. So let's go. X times x is x squared plus x times 1 is x. So that carries down. Just trying to keep my terms under each other. Otherwise I get a bit disorganized and I lose track. Now 3 times x is 3x and 3 times 4 is 12. Now I can see 2 like terms. I can see 1x and 3x. So let's solve that, or sorry, we should simplify that. Now this is expanded. Now this line, when I collect like terms to simplify, okay, so x plus 3x equals 4x plus 14. Okay, let's have a look at one other one over here. So m times m equals m squared plus m times 2 equals 2m. Now carry that plus down, plus 3 times m, which is 3m, plus 3 times 2, which is 6. I can see 2 like terms. It's nice there in the middle and next to each other. So equals m squared plus 3 plus 2 is 5, so 5m plus 6. I will do this one just because it's painful because of the negatives. So let's have a look at this one. We've got y times y equals y squared. Now we've got to take 5y, carry that, take down, 2y. Now we've got a negative 2 multiplied by negative 5. So a negative 2 times a negative 5, well, that's got to be a positive 10. I can see 2 like terms, so I can simplify by collecting like terms. So that's y squared. Negative 5 take 2 is going to be negative 7y and then plus 10. So that's 2 lots of single brackets, this sort of question here. Now let's have, now these are we going to use 2 lots of brackets. So I might do the ones down below. I might do this one this way first of all. So x plus 9 and y plus 3. So that's xy. That's 9y. This is 3x. And 3 9s are 27. So I can just collect like terms and simplify. So I've got xy plus 9y plus 3x plus 27. There are no like terms in there, so they are just simplified. let's have a look at this one here. K plus 6, P minus 2. Let's do a FOIL for this one. So I'm going my first terms, then I'm going to go my outer terms, then my inner terms, then my last terms. So multiplying my first terms, we got P and a K, so that's KP. They're all pluses in front of that, so let's do outer now. And we've got a negative 2 times K, so that's going to be a negative 2K. Now let's do my inner. I've got a plus 6 times P, so that's plus 6P. And let's do my last. I've got a plus 6 multiplied by a negative 2, so that's got to be a negative 12. I can see no like terms, so that's simplified. And let's do crab claw for this one. So I'm going to get the top and I'm going to multiply the first term by the other two, and then I'm going to get the second term and multiply it by the other two. So we've got FG and then take 1F, and so that's just F, and then we've got a plus in front of the 4, so plus 4G, and then a plus 4 multiplied by a negative 1 equals take 4, and that's simplified. Now I've spoken quite a lot, and I'll get you to work on your mastery exercises from there.